Okay. We're back. And we're going to see how much farther we can get to actually getting uh, SPIRiT working. I have learned the hotkey for changing the size of the font. So now when I hit find, the find window comes up here. That's already a major improvement. And we're going to see how much farther we can get to actually getting. Okay. So one thing I'm going to do is just set up a check. I'm going to make sure that we have enough equations to find all the coefficients. That is, I'm going to make sure that the system for determining the coefficients of the interpolation kernel is indeed at least square. But, I would like it to be overdetermined, but square theoretically is good enough, so we'll keep it a square. No. The size of the ACR is too small for this size kernel. That'll prevent us from having to deal with that issue that we dealt with last time, where A was underdetermined. And now I'm going to look at the interpolation coefficients for the first coil. I don't know why MATLAB does that. Every time I go to let it use go to copy something, I guess macOS is asking me if I should let MATLAB have access to the clipboard or something, wherever things get stored that you copy. I'm sure there's a way to say just let MATLAB have access to the clipboard once and for all, but I don't know it. Okay, so here we've got the interpolation coefficients. So my question is, I'm not going to be able to add y hat to a static workspace. Oh. Okay, so here's y hat. And what's the difference between y hat and y? Relative difference, 80%. That's not good. So it is not doing a good job of finding linear interpolation coefficients that satisfy what I'm calling the spirit condition. There's an outside chance that it's just this random data set. Oh. Let's just load another data set and make sure it's not something funky with this data set. I don't think it is, but you never know. 30%, that's still terrible. So no, it's not the data set. That suggests to me that there's a problem with this code here. And the issue is that I don't remember this code here. Okay. Okay, so I and J are the indices of the center location of the kernel as it slides across the auto-calibration region. Right? What is N and M? Little n, little m. It's got to be the size of the auto-calibration region, right? I'm thinking it might be better to just use SACR1 and SACR2. All right, what's happening here? So these two loops are iterating over all the locations where the kernel is fully contained within the auto-calibration region. This extracts out that portion of the auto-calibration region. This converts it into a vector. Okay, we'll look at point to remove in a second, but that seems to be right because we checked it last time. But we didn't check it for all coils, did we? Let's do that. Well, that's really just checking this. Well, I guess that would be right. Okay, so the zero's in the center there, and the next one should be here, the next one should be here, etc. Let's see if that's what happens. It's the second one. It's the third one. It's the fourth one. Fifth one. Okay, that's working. Point to remove index is in the right spot. That's good. Okay, so going back here. This takes out the sub ACR, stores the Y value. This is the value that's going to be interpolated. Then it takes out all the data around that point. And turns it into a one-dimensional vector. And then it stores it as a row of A. So A times W coil should equal this value of Y. What is the norm of Y? 3. What's the error? Not the relative error, but the error. 2. I should have known that because it's 80%. This shouldn't help, but let's see what it does. Relative error is 95%. That's what I sort of expected, actually. Do I just need a larger kernel? Now the auto calibration region is too small. Let's make that larger. Relative error is still 80%. And if I make the kernel 11, 63%. If I make it 13, 36%. If I make it 19, I'm needing a larger and larger auto-calibration region. That's not working. It should do much, much better than that with a much smaller kernel. How do I know? Because Grappa is amazing. Grappa is simpler than SPIRiT, and it works. That's conjugate transpose. That should have just been transpose, but it's conjugate transpose. And now the error is very small. Let's take a look at the image. Error of 1% is not tiny, but it's not terrible. So this seems to be taking a while now. Still terrible aliasing. Man, pretty tough. Okay, now let's check. We got an error of, the worst error was 1% or so with a kernel size of 7. What does this kernel size of 9 get us? Not a large enough auto-calibration region. Okay, the errors actually got worse. That's because the auto-calibration region is larger, so it's trying to satisfy more equations. And this, by the way, well, if this is right, this is why I embarked upon the project that we're currently embarking on. The reason why Grappa and SPIRiT work is slightly complicated, but if you're interested, you can check out this paper that my student wrote. The dependence of parallel imaging with linear predictability on the undersampling direction. For Grappa and SPIRiT to work, it makes certain assumptions, right? Like why would the coefficients, missing coefficients in the missing Fourier coefficients in K-space be the result of a linear interpolation of nearby values? Why would that be the case? Well, that paper answers that question. And so So what? So it's not, those assumptions are approximations, the assumptions required by Graph and Spirit. How much of an approximation? Well, this much of an approximation. And so we can encourage solutions to satisfy the Graph and Spirit condition, that nearby coefficients are related by a linear interpolation. But only to a certain point, only to this degree. That's the idea. I'm thinking this is right now. I'm thinking that's not the issue. Actually, I have no idea what the issue is, so. So let's keep those statements around. Now the question is, what do we do? Okay. I think I'm realizing again that we didn't actually need to store W as a four-dimensional array. We could have just iterated over the coils and used a three-dimensional array here. Why didn't I do that? I don't remember. So I'm guessing, though I don't know, that if we look at K-space again, we're still going to see that stripe pattern. That's what I'm going to look at now. Going back to 7 and 31. Going back to 5 and 31. It's still there. But maybe not as bad. Of course it's not as bad. I solved a terrible bug. But it's bad enough to be causing aliasing. And why is it doing that? Why is it doing that? Here it's particularly bad. Yeah, so here's the aliasing that was particularly bad. Okay, here's a question. We've checked basically this now, but we haven't checked this, right? So my contention is that convolving the auto calibration region with this vector is the same thing as multiplying A times W coil. I think it's going to be easier to work with W as a 3D array rather than a 4D array. Or does that change everything? Yep, it changes everything. Oh, apply W. Iterates through all the coils. Of course, we need to store all the, okay. It would have been easier, but whatever. Okay, so now this W is equal to okay, now again, I think that if I convolve I guess if I apply W, is that the question? If I apply W, I think that if I apply W, that should be the same thing as multiplying A times W coil. Applying W to the auto calibration region should be the same thing as A times W coil. It's not quite the same thing because apply W does a circular convolution. Where is that? Here. And there are edges, so it's only going to be the same on the interior. Let's see if that's what happens. So then apply W. Okay. Apply W goes through all of them, so let's see. So, okay, apply W K to K data, right? I should be able to do it just to the ACR. Does the ACR get extracted somewhere? I'm sure it does, right? Yeah, there. Where does that get used? Gets used there. Then why are we creating it all the way up there? Now I just want the interior. And y temp is equal to temp. So this should be the same thing as y hat, I believe. And what I was hoping to do was just to not do this outside of the loop and do the comparison in here. That's why I created the this W thing. But then I wouldn't be able to use apply W. I would just use circular convolution with the sum. I'm going to check to make sure that's the same as y hat. Let's see if that even runs. It doesn't even let me set a breakpoint. Line 129. Forgot to crop the interior. Oh, I think we're calling N coil C. Is that right? C. Where does C get set? Why do I call it C? This should be N coils. Invalid syntax for calling function crop data on the path. We're not going to use this, so that's not. Okay, so, wow. Huh. That was strange. I wonder what happened there. Number of elements must not change. Reshape W size. One times 31 is 961. Y hat 729. Are these the same size now? So this is 676 and that's 729. No, those are not the same size. Why is that? Do I need +1 here and here? 729, 729. I did need that. 1 over 100% difference. Okay, so my contention is currently incorrect. Doing a circular convolution is very, very different than multiplying A times W coil. We're about 35 minutes in. That is very confusing. I don't want circular convolution. I want cross correlation. That is incorrect. The difference between circular convolution and cross correlation is that the argument is flipped, right? So I created before flip all dims. I don't like that function anymore. I'm going to call it flip dims. I want to pass in a parameter called dim indexes, or just dims. We're going to put this straight into dwarclib. A 1D array specifying the indices to flip if not provided all dimensions are flipped. So these can be positive. They would be integers, but whatever. In Python, we would say for, maybe like for each I in dims, something like that. I never figured out how to do that in MATLAB, the equivalent thing. This is what I do. I'm sure this is inefficient, but I just don't know how to fix it. Let's add some usage. Is this using flip all dims? Now I think it can use flip dims. That test passes. The adjoint test for circom passes. Circom 2 fails. Flip dims. Expected a oh right, because I didn't right. I could have made it an unnamed parameter. Not a so what do they call it? You can add optional, not a parameter. You can add optional. So I guess it's an optional parameter. It's unnamed. I guess it's an optional argument. But this seems a little cleaner, doesn't it? Like it's telling you you're going to flip the dimensions. Which dimensions? These dims. These dimensions. Okay. So now if I test dwarklib2 circular convolution, looks like that's passing. Looks like I'm only checking the adjoint. And circconv1, I don't think needs to flip more than one dimension, right? So we don't have to worry about that. Great. Okay, so terminal. Let's clean up dwarklib a little bit. All right. Just to check, going to make sure that the difference to circcoms is only what I thought it was. It is. I'm going to remove flip all dimensions. Flip dims to the repository. Let's push that. What's the difference with stats? I seem to remember doing something minor with stats. Why is this taking so long? Oh yeah, we added these indice things. Made stats more informative. Great. Flip all dims should no longer exist anymore. And it doesn't, just flip dims does. Great. Where's apply W? The first argument is W and the second argument is in. That's right. Circconv, I think, is flipping A because this was the big issue that we've had long ago. Not long ago, a few days ago. Many, many bugs ago. So what do I do? Do I create a cross core too? Wait a second. Okay, so with circconv 2 at least, I thought at some point I was comparing to MATLAB's convolution. And I don't see that right now. So let's look at this, circconv 1. I thought at some point I was comparing to MATLAB's convolution. Did I delete that when I made all these changes? I am flipping K. Okay, so I'm flipping K, not A, then doing a whole bunch of sum of circular shifts. So a whole bunch of sums of circular shifts. And that should be that is convolution. Okay, so circconv 1 is certainly doing the right thing. And it's got these flips in here, fine. What is the convolution theorem? The Fourier transform of u involved with v is equal to the Fourier transform of u times the Fourier transform of v. So now I'm confused. Here I'm taking the Fourier transform of u and the Fourier transform of v. I don't think I should have to flip anything. Right, I want to implement circular convolution. The convolution says that the convolution of this with the convolution of this with this is the inverse Fourier transform of the Fourier transform of this times the Fourier transform of that. But then there's a whole bunch of questions like, if I'm actually doing cross correlation, why isn't this working? If this is actually cross correlation, why isn't this working? Because I'm not flipping anything up here. So this is me doing convolution is the flip and shift operation. It's like native implementation. Flip, and then the shifts. And that's equaling circular convolution 1. It's equaling the result of circconv 1. And in here, I'm doing this flip. Why is that happening? Out of curiosity, if I do flip A instead of flip K, does this still work? No. Relative error is 0.2. Well, that passes. I shouldn't have to flip. I shouldn't need any of this. Well, I need the transpose, but I shouldn't need the flip. Oh, I'm not flipping. I'm only flipping on the adjoint operation. That makes sense. So I'm going to apply W. There is no, okay, so, okay. There's only a flip on the adjoint operation, which is correct. Oh no, with cert convolution 1, yeah, there's only a flip on the adjoint operation. I got to stop thinking otherwise. Okay, without, this is actually doing convolution then. If I'm not asking for the transpose, it's just doing convolution. Great. Okay, and that's why everything makes sense. Okay, so then we're back to SPIRiT. Let's see what differences we made to work lib. be doing this a lot, so I'm just going to put this on a different desktop. Okay, very minor changes. Forgot to put in the parameter again. Maybe I should make it an argument. I seem to want to use it that way. And now it's doing the right thing. Now this is actually cross correlation. Which is the same as convolution with a flip. So I could solve this like this. I think. Let's do checks. Will the adjoint test for applied W still pass? Flip too many arguments. Forgot. Flip dims. Okay, the adjoint test for W passes. Why isn't that a good solution? Because now, when you pass in, when you ask for the adjoint of the circconv2 operation, it flips. We're already flipping the input. If we had a cross correlation operation, we just wouldn't do the flip here, and we'd only do it here, eliminating, a flip. Or we'd only do it when we're not in the adjoint operation, which would eliminate a flip. Right now, if we're asking for the adjoint, we're flipping, then unflipping, and so that's a slight inefficiency. But we now have I think we're not actually using apply W here, right? So it could be that, there's still a bug in apply W, even if we now see that cross correlation with W is correct. So what if we say apply W? Wait, no, W is, so now what do? We're going to apply it to the auto calibration region. We're actually going to see that apply W gives us the same thing as doing this. That's what I'm checking now. The issue is that I'm not saving these Y hat. Can I grow Y hat like that? Guess we're about to find out. Looks like I can. Okay. So now I can compare the output of this Y apply W to the output inside this loop. Does it need to be on K data? Five, 8, 3, 2, 729. That's not right, is it? Oh, 729 by 8. Okay. And look at that. Numerical precision to the error. Okay. How many more bugs could there possibly be? Really? Things got worse. Significantly worse. Oh, I changed the size of the auto calibration region. All of these errors are to within numerical precision. So this is doing what I think it does. Let's look at K out again. Those are the individual images, and they're terrible. That's not what I wanted to see. That looks pretty good to me, right? Wait, what just happened? I just want to look at the first coil now. Okay. Zooming in now, we see that there are still some stripes going on. Of course, there'd have to be, but feels like the issues are becoming less subtle or more subtle. Oh, this shouldn't be for coil 8, should it? Okay. So, totally as an aside, Jonathan Blow made this video. And here he talks about, how many lines of code your average programmer writes a day, right? He says the average programmer writes like 10 lines of code a day. Okay. Do I do better than that? Well, in a sense, no. Like, I haven't written a real useful line of code in a few days. All I've done is debug this code. So how are lines of code counted? Have I written basically 0 lines of code for the last 3 days? I don't know. It's not just that we're not running LSQR for enough iterations, are we? Is it like, is LSQR converging? It is converging. With terrible aliasing. Let's try one more thing. Yeah, that wasn't it either. I thought maybe, I don't really know that SPIRiT will work with a kernel size of 5 by 5. I don't really know that. Or an auto calibration region of 31. But I think it will. I think it should. And I think I've seen Grappa work on this data with a kernel size of that or less. So I don't think that's the issue, but it's worth trying. Where are we at? No longer need this, right? Because this test is a subset of this test. Is there anywhere else that I've got this quote doing a transpose? No, okay. Or at least not here. Ooh. I didn't notice that before. These errors are bad. I was just looking at these numbers for Y temp. But these numbers are bad. Oh. Right. But so, okay, so this goes back to the earlier conversation. This is about as well as we might expect the SPIRiT condition to hold. Okay. Here's the relative error that for operations, and this is within numerical precision. And so the question is what to do next. And I think one answer is stop streaming, and we'll see if we can figure this out next time. We got a bit farther. Tell you what I'm going to do. See, these are all the changes that we made today. This flip here was a crucial change that needed to be fixed. Is that the only bug we fixed today? Looks like it. Okay, so now we're in. We solved another bug, and 5 more to go. Both repositories are up to date, and that's going to be the end of this stream. If I get a lot of work done today, we'll see if we can stream again later. Thanks for your attention.